Okay, so today, this one, we're going to talk about definitions. So in mathematics, we clearly define things, and sometimes, even as we've seen in class or in previous questions, even a textbook can be ambiguous, particularly at the high school level. So we got to be cautious no matter what. A good example is 0. Is that positive or negative? It's generally defined as a non-negative. And they don't say positive. We actually use a technical term called non-negative. And 0 is defined to be a non-negative. Because if you say positive, it is restricting it to only positive, and that means you're kind of leaving out the 0. So a non-negative implies 0. It's weird. Okay? Positive, you're only starting at like 1. Anything above that. But non-negative, well, you're including a 0, right? So these are the little things that textbooks can be unclear about at times. So this is why it's so vital. Clearly define things, and this is where, as a teacher, I kind of guide you what is and what is not. And sometimes I even get it wrong because I have to go back and look at some definition, and I'm not sure what they're using, and it's some other definition, right? So it varies, but I'll try always make it as clear as possible. Rational numbers, which are is this idea of it's a fraction, right? Those are rationals, and rational, of course, is our q, though that's what we're talking about. P and q are integers, right? So this is positive, negative whole numbers. Q can't be 0, right? So can't divide by 0, and integer is even. There we go. That's what I talked about the other day, actually in class, but 2k will always produce, and k is some integer, so these are all your negatives, positive, negative, even values, and this is all your positive, negative, odd values, right? So these are two ways to describe odd and even numbers, and so on. So how do we deal with this? So how to prove this? This is something a technique you learned in grade 9. So this is, just recall how to do this, and believe me, really in high school, this is the only time I've forgotten how to do it. This is the only place in my life I use this. Beyond high school, it is not used. There's other points of discussion. This is a concept, this is a great example of what dies in high school. So what we can say is x is equal to 0.13, and basically what you want to do is expand this. So we're going to just say x is equal to 0.13, and that bar is saying that just repeats. Dot, 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 right? So what happens if I multiply both sides by 100? So I'm going to multiply both sides by 100. If I multiply this by 100, well, it moves this decimal 1, 2 down to 0.131313 dot, 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 dot. It keeps going. So what you can do at this point is then subtract one from the other. So I can say, I'm going to take that and subtract it. So I'm going to say minus x, and this is going to be 0.131313 dot, 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 dot. And then if I do that, I'm going to be left with 99x here, and this is going to be left with 13, and therefore I have x is 13 over 99. And I have a perfect fraction, which belongs to my rationals. And that's how that works. So that's pretty straightforward. The next one's a little more complicated because you have to really start to see what proving is about here. So again, we're going to say let x and y be two rational numbers. So what does that mean? By definition. I'll just say by def, okay? There exists, and this is there exists, right? So this just means there exists, or you can write just there exists, right? There exists PQ belongs to integers where Q cannot equal 0, so that X equal P over Q, right? Next, by definition, there exists an RS, element of integers, where S cannot equal 0, so that Y is equal to R over S. There you go. So what we have then, if we know that X and Y are two rational, right? So they belong to this. This is an element of their rationals. X and Y are rationals, right? So X plus Y, P over Q plus R over S. Well, that would then give you PS plus RQ all over QS, right? So there you go. So now we do have, this is still now a fraction, but here's what we can do. We can simplify this. We can say we do know that since P, S, R, and Q are integers, right? There are integers. The result is also an integer. So that would then mean we can call this, which we call P, right? So we're basically saying this whole term we're going to call this, the numerator, P, all over, and we say the same thing, since QS are integers, the result is also an integer, which we call Q. So that would then just be Q, right? So that therefore X plus Y is equal to PQ, where PQ belong to integers, and Q cannot equal 0. And then that's it. Therefore, by definition, by def, X plus Y is a rational function. or rational number. This is more like a mathematical proof. And yes, they are this long. This is actually a very short proof. Proofs can be hundreds of pages long. So at university, those that would go on to much more advanced mathematics, you're going to see much longer proofs. So this is a nice short version of one. Okay, so that's a good example of a lengthier style of writing. But that's actually writing math. And you can see that no numbers are involved. We're just talking about numbers and how abstract this idea is. Right? So there you have it. That's how you can prove that the sum of any rational numbers is a rational number. And you've done it for all of them.